Alright, so we're ready for section 6.2, which is how the normal model. So two things that main things we're going to focus on are being able to find probabilities using the normal model, and also finding values for a random variable given a normal probability. Alright. So the normal model is one of the most widely used probability models for continuous numerical random variables. Right? So remember, we also call this the bell curve because of its shape. Right? So on the next slide, remind us of the normal model. Right? So remember, we have something that's symmetric and unimodal. Right? So here's an example of a histogram that fits the normal model. So something to keep in mind is we do need mean and standard deviation when talking about the normal distribution, because they can look a lot different, right? So here's an example where we have two normal distributions that have the same mean, but they have different standard deviations. And you can see the blue has a larger standard deviation, right? So it's more spread out, where the red has a smaller standard deviation, so it's more closer together, right? It's taller, closer together. So these two normal distributions have the same mean but different standard deviations, right? The area under both curves is still 1, but how that area is distributed is different, right? So we need to know mean and standard deviation. On the next slide, we look at, well, what does two curves look like if they have the same standard deviation but different means, right? Two normal curves. So here's an example for heights, right? We have women and men, and their normal distribution curves have the same standard deviation, right? But their means are different, right? Where their center is different. So here I just wrote, so these normal curves show the distribution of heights for adult men and women in the U.S. Notice that the spread of each curve, the standard deviation, is about the same, but the center of each curve, the mean, is different, right? So that's what we want to pay attention here. So these two slides were just to remind us and to point out that when we're trying to find the area under the curve, we do need to know the mean and the standard deviation in order to find that, because that can mean different things, right? So some notation that we use. So remember, we use mu to represent the mean of a probability distribution, and we use the symbol sigma to represent the standard deviation, right? So then, if I use this notation, capital N, and then in parentheses, we put the mean first and then the standard deviation. And that tells us that we have a normal distribution, and the first number is the mean, and the second number is the standard deviation. Right? So, for example, if I wanted to show a normal, so let's say we had a normal distribution with a mean of 0 and a standard deviation of 1, right? Then I would show that with capital N and then 0, 1, right? That's what this information tells me. That I have a normal distribution centered at 0 and standard deviation of 1. Right? So we are going to find probabilities with technology in the class. So to be able to do this, just some hints. It is always helpful to sketch a picture of the area that we're trying to find, right? And then our technologies are going to require us to put in the mean and standard deviation, so that way we can find this normal curve, right? So I'm going to show you how to find this using the graphing calculator, TI-84, and also R. So first off, looking at the graphing calculator. So if we want to find a probability of a normal distribution on the calculator, you do these steps. You push second and then DIST, right? So let me open my graphing calculator. DISTR, right? The distribution is the blue right above the VARS button, right? So you can see here, right beside clear, is the distribution button, right? So you hit second. Oops, first we got to turn it on, right? So you hit second and then the distribution button, and that'll pop up, right? And then we want the normal CDF. So I hit the down arrow, hit enter, and there's the normal CDF. So we're going to enter in the lower, the upper, the mean, the standard deviation, and then we'll be able to find that value, right? And just a note that if you want something that's infinity, actually I noticed I have this backwards. All right, let me fix this. Alright, so you want to fix this in your notes. This should be positive 1 E99, and this should be negative 1 E99. Right? So you want to fix that. I'll try to fix that on the PowerPoint on Canvas. Right? So if you want to get positive infinity on the graphing calculator, you code that by doing 1 E99. And to get negative infinity, you do negative 1 E99. Right? So by default, you can notice the lower bound is negative infinity set to that already. Right? So let's say you want to go to positive infinity for the upper, you would do 1 alpha and then find E, which is here, and then 99. Right? How you can do that. Alright, so I'm going to quit out of this, minimize this, and continue on. Right. So then in R, we're going to use the pnorm command. So with the pnorm command, we're going to put in the specific x value that we're looking at, type in the mean and then the standard deviation, and that will give us the probability then, right? The area under the curve. But when you use the pnorm command in R, you're always given the left area, right? So if here's my normal distribution, whoops, I had a lag there, sorry about that. So if I have a normal distribution, and maybe this is x equals 10, right? If I type in pnorm, so let's say this is centered at, I don't know, 8 with a standard deviation of 2, right? So if I wanted to find this, find the area to the left, right, of the curve, so it'd be going from negative, or it'd be going from positive 10 all the way to negative infinity. I would type in pnorm and then 10, comma, the mean, which is 8. So here's the mean, and then the standard deviation, which is 2, right? And this would give me an output of the area to the left. So in other words, this would tell me the probability of x being less than 10, right? Would this command, right? So just as an example. Alright, so here's an example to work through, and I want to find this using the graphing calculator, the R, and then also I'm going to show you how to use a table in a moment, right? So we won't be using tables on the exam. I would like you to use your graphing calculator, so you want to make sure you know how to do that using the graphing calculator. Right, but I also want to show you how to use a table because that's commonly taught in stats, right? And the table is really just to give an option if you don't have a graphing calculator, right, or technology available. All right, so example, women's height. So we have a normal model, so n and then 64, 3, right? So remember, this is my mean. So we have a mean of 64. And I have a standard deviation of 3, right? So we have the normal model gives a good approximation of adult women's height in inches in the U.S. Find the probability that a randomly selected adult woman from the U.S. is between 62 and 67 inches tall, right? So to kind of draw this, so we have a normal distribution. Here we have a mean of 64, right? And I want to find the probability of someone being in between 62 and 67, right? So in doing this, to find this probability, I essentially want this area. Right, I want to know what's the area, all this area. Right? Oops, we still have my mean of 64 here. Right? So to do this in the graphing calculator, right? So let me pull up the graphing calculator. It's pretty easy, right? We're gonna go to second, then distribution, and then we want to go to normal CDF, right? So the lower bound in this case would be the 62, right? So I type in 62, and then the upper bound is 67, right? So this is the lower bound for my area, and this is the upper bound. Right, that's what contains this area. So then my mean is 64, and my standard deviation is 3. So we can go down here to paste, and what this does is it already puts it in the format that we need to put it in the calculator. And if I hit enter, it'll give me back that area, right? So this area underneath here is 0.589, right? If we round to the nearest thousandth, right? So the probability that x is in between 62 and 67 inches is about 59% roughly, right? Or 0.59. Depending on how many decimal places that you'd like, right? So if we go on the next slide, I just had a more computer-generated picture here, right? So here, this is 62 to 67, right? Find the area in between. So to find the TI-84 graphing calculator, right? So my graphing calculator in yours may also have the prompt where it just has you input the inputs, and then it types it in this fashion for you already, right? But if you don't, this is how you would do it, right? You do lower bound, upper bound, and then mean, and then standard deviation, and that will give you the p-value, right, in that order, right? So next I would like to show you how to do this using R. Alright, so let me do some erasing here. So our question still is find the probability that x is in between 62 and 67, right? And we have a normal curve of, let's see, 64.3, right? So remember, here's my mean, here's my standard deviation. Alright, so let me open up R. So R will allow us to basically not have any tables, right? So that's the nice thing about having computer software. Also, I'm going to show you tables in a minute, but those are approximations, and sometimes we're not able to find what we need, right? So using R is very helpful, right? So as I told you before, we're going to use the pnorm command, right? Pnorm. But using this command, we always find the area to the left, right? So for example, if I typed in the pnorm command, so we type in the x value, so 67, comma, and then I type in the mean 64, standard deviation of 3. What this is going to do, this is going to give me the area to the left of 67, right? So here's my value, here's 67. This command in green is going to give me all of this area, right? All the way to negative infinity. right? But the problem is I want to stop at 62. I want to stop here, right? So if I use the command pnorm 62, 64, 3, that'll give me all this area in blue, right? So if I only want this area here, so this area, what I can do is I can subtract these two areas, right? So if I take the area of the left of 67 and then subtract off the area to the left of 62, I'm left with just what's inside, right, in the middle. So the command I really want is pnorm 67, 64, 3, and subtract off pnorm 62, 64, 3, right? So just to go over this again, right? Here's my normal distribution. Here's 67. Over here is 62. Right? So the idea is I want this area here. So to find that area, one way is to find the area all the way over here, right? And then subtract off, take away this area, right? All this area from 62 to the left, and that will leave me with the area I want, right? Which is here, right? So to do this in R, right, you would type in pnorm 62, 67, sorry, 62, 64, 3, and then subtract off pnorm 62, 64, 3, right? So that gives me the 0.588, right? So if I did just this command, right, that would be all the area to the left, and then if I did just this command, that'll give me the area to the left of that, right? And then the difference of those two is the area I'm interested in, right? So when we use pnorm, sometimes you might want to use, just typing in a command to find the area to the left, or you might want to subtract some, right? So it's really important to remember that R always gives you area to the left, right, with pnorm. And we're going to find in a moment with the table, that's always true with the table also. The table always gives you area to the left. So if you want the area to the right, you would have to take 1 minus the area on the left, right? Because remember, all the area underneath is 100%. Right? So we got the same solution, right, with the graphing calculator and with R, right? So with the graphing calculator, we got 0.588 also, right? So you can see that we get this, it matches. Alright, so then the next slide talks about without technology. So it's really, we'd have really big tables if we didn't convert everything to what we call standard units, right? So without technology, what you would have to do is take your x value, convert it into a z value, right, a standard unit, and then look up on the table with what we call the standard normal table, right? So I showed you before what a normal distribution is, right? So let me scroll down. So what we call a standard normal distribution is when we have a mean of 0 and a standard deviation of 1, right? So this is where we use z-scores, right? So again, a standard normal model is a normal distribution with a mean 0, standard deviation of 1, right? And this is how we write that in symbols, right? So when we look up in the table, this is what we're talking about, right? Or if you're talking about z values, this is the distribution you're talking about. So remember how to calculate a z-score is we take the x value minus the mean divided by the standard deviation, right? So remember z equals x minus x bar all over s. Right? So here's another example, and I'm going to solve this problem using the table. So it says a small newborn seal pups have lower chance of survival than larger newborn pups. Suppose the length of the newborn seal pups follow a normal distribution with a mean of 29.5 inches and a standard deviation of 1.2 inches. What is the probability that a randomly selected newborn pup is shorter than 28 inches? Right. So in this case, my mean is 29.5 inches, and my standard deviation is 1.2 inches. Right? So I want to convert this. I want to find the related z-score with this x value of 28 inches. Right? So I want to find the probability that x is shorter than, so less than 28. Right? So this is the same thing as finding the probability that z is less than, and then I need to find what's the z-score that goes along with 28. Right? So we're going to use this equation above, right? So z-score associated with 28 is equal to 28 minus the mean, which is 29.5, divided by the standard deviation, which is 1.2, right? So in other words, z-scores, remember, tell us how many standard deviations are you away from the mean, right? So if we do this, let's see, get our graphing calculator, right? So we take 28 minus 29.5 and then divide by 1.2, we get this. So I get a z-score equal to negative 1.25, right? So we need to keep this in mind. So this is probably less than negative 1.25, right? And if you are a more visual person, right, if you want to visualize this, let me make the OneNote larger so I can draw this a little better, right? So if you want to visualize this, right, basically what's going on is we have a normal distribution, right? Underneath, this is my x-axis, and then I'm drawing a z-axis down here as well, right? I know that I have a mean of, 29.5, right? So that's the center. And that, the corresponding z-score is 0 for that, right? So this is the center of my normal distribution. So what I'm trying to find is what's the probability that that we have an x value less than 28, right? So if here's 28, then this area to the left of 28, this would be the probability that x is less than 28, right? Which we can perfectly do. I could easily do this in my graphing calculator R, right? But again, when we do a table, I'm not going to have a table for every mean, every possible standard deviation out there, right? That's crazy, right? So what we do is we turn this into the standard z-score, and we can use the standard table, right? So I'm trying to figure out, well, what z-score corresponds with 28, right? So I used this formula, right? And we found that corresponds with negative 1.25. So the distance in between the mean and the value we're looking at is 1.25 standard deviations to the left, right? So now I can look this up on my table and find the same thing. And remember, the table gives area to the left, right? Just like in R. So area to the left. It's important to remember that. So let me open up the textbook. So the table, just to show you where the tables are in the appendix in the back of the book. Let's see, preface. Oh, here's appendix. So if you open down chapter 10, they put it in there. So appendix A has tables. So here's a table of random numbers that we've talked about before. If you go to the next page, here are the tables for the standard normal cumulative probabilities, right here. So we're going to use this table, and this first page, notice all my z-scores are negative. And if I go to the next page, all my z-scores are positive, right? So depending if you have positive or negative, depends on which page you're going to use, right? And it reminds us that the cumulative probability that we're looking at is to the left, right? So here's a little picture, a diagram to help remind you of that, right? So what we were trying to find was a z-score of negative 1.25. So since we're negative, we're going to look on this page. So let me show you how to read this table. So the tables go to 2 decimal places, right? So if we had more than 2 decimal places, you'd want to round to 2 decimal places. So what I'm looking for first is negative 1.2, right, which is here. So my probability is going to be somewhere on this row, right? And then what you're going to do next is look up at the column. So the columns are labeled by, so this is showing you like the first decimal place. Up here is showing you the second decimal place, right? So if I went negative 1.25, I find where negative 1.2, so let me zoom out a little bit so we can see both. Let's see, we want this. So here's negative 1.2, and we wanted to find where does that correspond with negative 0.5, and that's this value here, right? So negative 1.25 z-score has 0.1056. That's the probability, right? So I have this also in the PowerPoint, but I got rid of some of the information we didn't need, right? So if I go back to the, see the setup I had here. Right. So if we go to the next page, here's finding the z-score, right? So we already calculated this. We get negative 1.25. And then when we're looking for this on the table, right, we're looking for a z-score, z-score of negative 1.2. So I'm looking at that on the left, along the first column. And then looking, where does that match up with the 0.05 column, right? So remember, this gives you the first decimal place value. This gives you the second place value. And that's 0.1056, right? That's where that matches up. And that's where we found it before, right? So that would be the probability, right? Because we were looking for the probability to the left. So the probability of z being less than negative 1.25 is equal to 0.1056. Right? So sometimes you might want to go backwards. So in other words, maybe you know a given probability, but you need to find the x value. So this is also true, right? So kind of doing this in reverse. So we know this answer, this probability, and we want to know, well, what goes here, right? What's the x value? So following the example before, right, with the seal pups, so the birth length of newborn seal pups follow the model normally distributed with a mean of 29.5 and a standard deviation of 1.2, right? Suppose pups with lengths at the 15th percentile and below are unlikely to survive. So we want to find, well, what birth lengths would make it unlikely that a pup would survive? Right, so let me go down here, right? So in other words, here's my normal distribution. I know the mean here is 29.5, and the standard deviation is 1.2. So I know there's some area out here where 15%, so this p-value is 0.15. Right, I know this information. I want to find, well, what's the corresponding x value, right? What's this? So we're kind of going backwards. So let me show you how to do that. So with the TI-84 graphing calculator, you can follow these steps, right? So we still do second distribution, and then you're going to pick the option where it's inverse norm. And then we're going to enter the area to the left of the x value of interest, the mean, and the standard deviation. Right? So let me open up my graphing calculator. So for this, I would go second, turn it on first, second distribution, and then we want the, right, as told here, inverse norm, which is option 3. So you can just hit 3, or we can scroll down and hit enter. So the area to the left is 0.15. The mean in this case is 29.5. And the standard deviation is 1.2. Right? So we can go down and hit the paste button, and that'll put it in this format already for us. Right? And we hit enter, and we get 28.25. Right? So this x value is 28.2. We'll do 56, right? Roughly, right? Right. So if a seal pup has this length, right? So anything below this length would contain 0.15, right? So in other words, another way to look at this is the probability that x is less than 28.256 is equal to 0.15, right? So we just did this backwards. So 15% of the pups are less than 28.256. See, this was inches, right? So here on my PowerPoint slide, I rounded to the nearest tenth. So that's how I got 28.3, right? So also I want to show you how to do this on R. Right. So let me pull up R. Right, so R, we're going to use the P norm or Q norm command, right? So here we use Q norm. So what we're going to enter first is the area, and then the mean, and then the standard deviation, right? To find the Q norm, right? Just as listed in the PowerPoint, right? So if I go back to the PowerPoint, here's what I told you, right? The p-value, which is also the area, right? Enter that, the mean, and the standard deviation. So to do this problem, we would do Q norm, and then type in the area, so we would have 0.15. The mean is 29.5, and the standard deviation given was 1.2. So I hit enter, and I get 28.256 still, right? So we get the same value as before from our graphing calculator. Right? Good. So something kind of difficult sometimes for students is, should I do normal or inverse normal? So I just want to walk through two examples and just identify, should we do normal or inverse normal problem, right? So number one says a clothing store manager wonders what percentage of our customers are taller than 6 feet, right? Number two is a clothing store manager wants to cater to the tallest 20% of men and wants to know what heights he should accommodate, right? So going to the next slide, I have the solutions, right? So the first one is a normal problem, right? So here we're trying to find the percentage. We don't know the percentage. So if you're trying to find the percentage, that's a normal problem, right? Or number two, if you know the percentage and you're trying to find the corresponding x value, that's an inverse normal problem, right? So So hopefully that helps make sense of that. So another thing I just want to remind you of, some of it in the homework, is the empirical rule, right? So remember, the empirical rule is for normal distributions, and if we are within one standard deviation of the mean, 68% of our data will lie in there, right? And then if we go 2 standard deviations out, 95% will fall in there. And if we go 3 standard deviations out, 99.7% of the data will be within 3 standard deviations of the mean, right? So this diagram shows that, right? And since everything is symmetric, if I know that 68% is between here and here, right, then that means 34% is on either side of the mean, right? So you can do that correspondingly to find all of these values. So knowing these values and how to draw this would be helpful, right? So you could draw all of this just by remembering 68, 95, 99.7 rule. You should be able to replicate this diagram, right, and be able to figure out these percentages okay if needed for like on the exam. Right? Alright, so that's all I had in the PowerPoint. I would like to go through some problems with you. Some more problems. Alright, so here I want to think about finding the p-value or the associated probability for given these situations, right? So part A, what's the probability that z will be less than 1.46 and so forth? And to start with, I'm using the standard normal distribution, right? So remember, whenever we use z, right, so we use z, this is standard normal distribution, and my mean, right, so my mean is 0, standard deviation is 1, right? So whenever you see z, you should be thinking this, right? Normal distribution, mean of 0, standard deviation of 1, right? So I want to start with this to make it a little easier. So let's look at A, right? So A is, what's the probability that z is less than 1.46, right? So less than is to the left, right? So this is area to the left. To the left. So if you draw this with a picture, so here would be a z-score of 0. Here's a z-score of 1.46. All right, if I follow this up to the curve, I want to know what's this area, right? Whatever this area will be equal to this, right? So I'm going to just do this in my graphing calculator, right? So that's what you want to be the most comfortable with, because that's what you'll use on the exam. So let me do split screen here. Right, so to find this, we go to second distribution, and then option 2, right, normal CDF. So my lower bound in this case would be -1 E99, right? Because we went negative infinity. I want to go all the way to the left, right? So this curve keeps going, even though it gets really, really close to the line. It keeps going on forever, right? So we code that by -1 E99, and that was already in by default, right? So then the upper is 1.46. 1.46. And then we already have a mean of 0 and a standard deviation of 1 by default, right? Already entered in there for us. So I can hit paste, hit enter, and that gives me the area, right? So this first one would be equal to 0. We'll do 3 decimal places, 928, right? So that's the probability that z is less than 1.46, right? Alright, so let me do some erasing to look at the next one. So the next one is, what's the probability that z is greater than 1.4? Alright, so let me draw another curve. So we got a normal curve here. So again, in the center we always have a z-value of 0, right? That corresponds with the mean, right? We want 1.4 to be to the right, and I want to know what's the probability that z is greater than 1.4. So if we go greater than, that's to the right, right? Because to the right are the values that are greater than. Right? So to do this in the graphing calculator, right, you'd have to go to second distribution again, option 2, normal CDF. So the lower bound in this case would be 1.4. Right, that's the smallest value. The upper value would be positive infinity. So remember, to code that, we would do 1 and then E99. And then my mean is 0, my standard deviation is 1, right? So leave that the same and then hit paste. Hit enter, and that'll give you that area. So whenever you find a probability, right, that should be in between 0 and 1, right? So whenever you get a p-value, that should be in between 0 and 1. So immediately when I see this is a negative value, something went wrong, right? So let me see what went wrong here. All right, so I figured out what was going wrong with the graphing calculator. Right, so this is the problem that we were looking at, right? And notice the p-value must be between 0 and 1. So when I got this value back, I used some quantitative reasoning skills, like, whoa, wait a minute, this can't possibly be right, right? So what was happening is when I do alpha e and get the e, this is not coding in the calculator correctly. It's a different e. So when you type in the calculator like 1e99, right? So alpha e and these e are different, right? So 1e99, what the calculator does is this is scientific notation for 1 times 10 to the 99th power, right? So if you want positive infinity, right, I'll have to look up how to get this e value, right? But in the meantime, what you can also do is just type in 10 to the 99, right? 10 to the 99th power. And that, because that's equal to 1 times 10 to the 99 power, right? So if you want negative infinity, you can type in negative 10 to the 99 power, right? So before, I talked about how we could enter in 1e99 for positive infinity and 1e or negative 1e99, which is true, but I need to figure out how to come up with this e value or type it in, right? It may or may not be possible, so I will get back with you on that. But in the interim, you can certainly use these, right? They mean the same thing, right? So to correct this, right, we go to second. So second distribution, we want normal, continuous. We want CDF, right? Continuous, and then so this e is not coding it right. So the lower bound was 1.4 still, but for the upper bound we can type in 10 to the 99th power, and this should work, right? So if I hit paste, hit enter, there we go. This seems a lot more likely, right? So this would be 0.08, roughly 81, right? If you want to do 3 decimal places still. Another way that you could do this is you could take 1 minus the area to the left, right? So like here, if here's the area to the left, so we could find this area. So if I want to find the red, right, the probability that z is greater than 1.4, this would be the same thing as 1 minus the probability that z is less than 1.4. right? So we could also do this, right? Do second distribution, normal CDF, and then the lower bound we could type in negative infinity, so negative 10 to the 99th power. And then for the upper bound, type in 1.4, and you could get this answer. And so that's the area of this blue, right, that I colored in. If I do 1 minus this, so 1 minus second, and then answer, hit enter, we still get 0.081, right? So those are two different ways to do this. In fact, if you were doing this in R, you would have to use this as your command, right? So let me show you how to do this using R. Right? So to do this in R, we would need to type in pnorm, we would want to do 1 minus pnorm, and then the x value is 1.4, or the z value, right? And this has a mean of 0, standard deviation of 1. Right? So if I do 1 minus pnorm, 1.4, comma 0, comma 1, that will give me this area in the red, right? If I don't do the 1 minus, that just gives me this area to the left, right? But I want the area to the right. So if I do 1 minus the area to the left, that will give me what's left over, which is the area to the right. So if I do this, I still get 0.081, right? Which is what we've been getting each time, right? Alright, so let me go split screen here again. Let me do some erasing. Alright, so we got those so far. So part B, or we did part A and part B. So part C, I'll move through a little quicker. It's just like part A, right? So we have a normal distribution curve, right? Here I have my z-score of 0. And then here I'm going to have some value of negative 1.49. I want the probability that z is less than negative 1.49. Well, that goes to the left. Right, so I want to find the area to the left, which we've done a few times, right? So if I hit second distribution and then go to normal CDF, the lower bound would be negative 10 to the 99th power. My upper bound would be negative 1.49. Then we just hit paste, right? So we get, so the area to the left of negative 1.49 is 0.068, right? And again, I could find that quickly with R also, right? So to do that, we would do pnorm negative 1.49, comma 0, comma 1, right? So mean of 0, standard deviation of 1, hit enter, and we get the same result, right? 0.068, right? And then so part D is a little different, right? We want to find the probability, the area in between negative 2.15 and 3.02. Right, so there's my normal curve, right? Here's Z. So I want to find in between negative 2.15, find this in between here, and 3.02. So I want to come up with this area right in the green. Right, so in the graphing calculator is pretty simple. we would type in negative 2.15 as my lower bound. My upper bound is 3.02. And we still have a mean of 0, standard deviation of 1, right? Because we're talking about the z, which is the standard normal, right? Hit paste, hit enter. We get point. So here we get 0.98. We'll do 3, right? Round to 3 decimal places. That's what I've been doing, right? So the area in between here is 0.983, right? And if I'm doing this in R, I could find the area of here all the way to the left, and then find this area. Then if I subtract them, I'm left with just right here what's in green, right? So the command in R for this, right, we would do pnorm 3.02, comma 0, comma 1, right? So that's the area to the left of 3.02, and then minus the area to the left of negative 2.15. Right? And doing so, we get 0.983 still. Right? So we still get the same result. So you can use R or the graphing calculator. Right? So again, make sure you know graphing calculator for sure for exam. But with R, that'll be used like in the R in the R assignments, and also just for your general knowledge, right? Where you might need to use R on the job. So here is, well, what if we just have any normal curve? So before I was looking at the standard normal curve, but what if we just have any normal curve? How do you find this? It's really quick, right? So if we go to second, distribution, and then we go to option 2, normal CDF, my lower bound would be 3.45, and my upper bound would be 6.69. My mean is 4, standard deviation is 2. I can go to paste, hit enter, and I find that area, right? So in the graphing calculator, and actually in R, it's pretty simple to do, right? And if you need to draw a picture, certainly do that. So here we have my normal distribution, right? Here we have 3.45. Over here I have 6.69. I'm trying to find the area in between, right? Where here, this is actually finding area in between also, right? So here's 8, here's 12. I want to find the area in between, right? What's probably the x's in between? So we already found that this probability is 0.52 roughly, right? So now we can find this one. So we would go to second, distribution, option 2. My lower is 8 now, upper is 12. My mean now is 15, standard deviation is 3. We hit paste, enter, and we get 0.15 roughly, right? So that's the probability for here. Right. All right, so that's all I have for this video. If you have questions, make sure you email me. Thanks.